Hello everyone, how are you all? Hopefully all of you are doing well. Welcome to my channel. तो आज की वीडियो का जो टॉपिक है वो है हमारे पास स्टेप्स एल्गोरिथम के। पहला स्टेप मैंने आपको पिछली वीडियो में बताया था। आज हम लोग दूसरे स्टेप से स्टार्ट करते हैं। Number second is analyze the problem. The purpose of this step is to determine both the starting and ending points for solving the problem. This process is analogous to a mathematical determining what is given and what must be proven. A good problem description makes it easier to perform this step. When determining the starting point, we should start by seeking answers to the following questions. Number one is what data are available, where is that data, what formulas pertain to the problem, what rules exist for working with the data, what relationships exist among the data values. When determining the ending point, we need to describe the characteristics of a solution. In other words, how will we know when we are done? Asking the following questions often helps to determine the ending point. What new facts will we have? What items will have changed? What changes will have been made to those items? What things will no longer exist? Number three is develop a high level algorithm. ये हमारे पास थर्ड स्टेप. An algorithm is a plain plan for solving a problem, but plans come in several levels. For detail, it's usually better to start with a high level algorithm that includes the major part of a solution but leaves the detail until later. We can use an everyday example to demonstrate a high level algorithm problem. I need to send a gift card to my brother Mark. Analysis: I don't have a card. I prefer to buy a card rather than make one myself. High level algorithm: go to a store that sells greeting cards, select a card, purchase a card, mail the card. This algorithm is satisfactory for daily use, but it lacks detail that would have to be added via a computer to carry out the solution. These details include answers to questions such as the following: which store will I visit? How will I get there? Walk, drive, ride my bicycle, take the bus? What kind of car does Mark like? Humorous, sentimental, risky? फिर है these kinds of details are considered in the next step of our process. Number 4 is refine the algorithm by adding more details. A high level algorithm shows the major steps that need to be followed to solve a problem. Now we need to add details to these steps, but how much detail should we add? Unfortunately, the answer to this question depends on the situation. We have to consider who or what is going to implement the algorithm and how much that person or thing already knows how to do. If someone is going to purchase Mark's birthday card on my behalf, my instructions have to be adapted to whether or not that person is familiar with the stores in the community and how well the purchaser know my brother's taste in greeting cards. When our goal is to develop algorithm that will need computer programs, we need to consider the capabilities of the computer and provide enough details so that someone else could use our algorithm to write a computer program that follows the steps in our algorithm. As with the birthday card problem, we need to adjust the level of detail to match the ability of the programmer. When in doubt or when you learning, it is better to have too much detail than to have too late. Most of our examples will move from a high level to a detailed algorithm in a single step, but this is not always reasonable for longer, more complex problems. It's a common to go through this process several times, developing intermediate level algorithm as we go. Each time we add more detail to the previous algorithm, stopping when we see no benefit to further refinement. These techniques of gradually working from a high level to a detailed algorithm is often called is a process for developing a detailed algorithm by gradually adding detail to a high level algorithm. Number 5 is review the algorithm. The final step is to review the algorithm. What will we Are we looking for? First, we need to work through the algorithm step by step to determine whether or not it will solve the original problem. Once we are satisfied that the algorithm does provide a solution to the problem, we start to look for other things. The following questions are typical of ones that should be asked whenever we review an algorithm. Asking these questions and seeking their answers is a good way to develop skills that can be applied to the next problem. Does this algorithm to solve a very specific problem, or does it solve a more general problem? Or does it solve a more general problem? If it solves a very specific problem, should it be generalized? For example, an algorithm that computes the area of a circle having radius 5.2 meters, formula pi 5.2, solve a very specific problem, but an algorithm that computes the area of a circle, formula pi r2, solves a more general problem. Can this algorithm be simplified? One formula for computing the parameter of a rectangle is length plus width plus length plus width. A computed formula would be length plus width. In this solution, familiar to the solution to another problem, how are they alike? How are they different? For example, consider the following two formulae. Rectangle area is equal to length with area is equal to 0.5. Similarities: each computes an area, each multiplies two measurements. Differences: different measurements are used. The triangle formula contains 0.5. Hypothesis: per, perhaps every area formula involves multiplying two measurements. तो ये थे हमारे पास 5 steps algorithm के to solve a problem. Hope you like the video. Thank you.